I made the following experiment, which consists in using 3 COB LEDs rated at 50 watt each. These 3 LEDs, I installed them in a 7.6 centimeter wide and 29.5 centimeter long heatsink. And I tested this configuration with 2 airflows, 20 CFM and 40 CFM. This is a photo of the installation of the LEDs. They are located at an equal distance between them, located just at the center of the heatsink. These are some thermal images, and because I want to get to this image, that is the lateral design of the heatsink with these dimensions. It has 2.2 centimeters in height, in fin height, and a base thickness of 2 millimeters. These thermal images correspond to the 3 measurements that I made. The first one is using a 20 CFM fan. The second one is using a 40 CFM fan located just at the center of the heatsink. And the last one is using 240 CFM fans. Each fan is located just above the LEDs that are located at the edges, which is this one and this one. In a short sentence, I can say that for this configuration, the only possible fan configuration that can be used is using 240 CFM fans to achieve the optimal output. And the reason is that even with one fan, 140 CFM fan, the consumed power is reduced about 1%, and for the 20 CFM fan, the power consumption is reduced about 9% with respect to the maximum consumption that I got with 240 CFM fans. This is important because a lesser demand of current translates into a lesser light intensity, and that affects the final application of the LEDs. That's why it's important to keep the temperature as low as possible. In this test, in comparison with the last test that I did with 2 COB LEDs, this time the temperature of the heatsink is above 60 degrees centigrade, and as you can see also in this table. And this causes the power consumption to decrease at around 170 watts for the 3 LEDs. For the 40 CFM fan, the average temperature of these 3 measurements that are located in this first figure, that are here, here, and here, the average temperature is about 45.8, and for the case of the 2 fans, it's 43.5. This temperature difference, the impact of this temperature difference can be seen in a difference in the power consumption, which is about 1%, as I said last time. Finally, one last observation that is very important for using this heatsink and this fan configuration for this number of LEDs is that the 40 CFM fans generate a lot of noise. It's actually so much noise that being in the same room with the lamp on, you can't stay there for more than 30 minutes or an hour before it's nerve wracking. So that's an important aspect to consider if you want to use this kind of configuration. That 20 CFM fan has actually the same noise as a PC fan, but as I have already said, it can be used for this heatsink. So if noise is not an issue, you can use the 40 CFM fan. If it is an issue, you should look for a bigger heatsink and the use of bigger fans with bigger diameter that in turn can be less noisy and can have a more airflow because the diameter is greater. And that's it for this week. Thank you.